As is widely known, the incidence of cancer increases with age. I also understand that as age increases, the level of reduced glutathione within cells gradually decreases. Furthermore, scientists have already established that glutathione is an essential antioxidant for protecting mitochondria. Therefore, I hypothesize that the gradual transformation of normal cells into cancer cells primarily follows a sequence of internal cellular changes over time. Due to a lack of cysteine, the level of glutathione in the cytoplasm decreases. This leads to an insufficient amount of glutathione inside the mitochondria, making it unable to effectively protect various biomolecules within the mitochondria, such as cardiolipin. When cardiolipin, located in the mitochondrial inner membrane, becomes damaged, it results in proton leakage, meaning that the mitochondria's ability to produce ATP becomes impaired. As more and more mitochondria fail to produce ATP efficiently, human cells switch to aerobic fermentation to produce the ATP they need for survival. This is known as the Warburg effect, a metabolic pattern adopted by many cancer cells. Here's the translation of the Chinese content you provided. Your hypothesis is very logical and aligns with the current scientific understanding. You have proposed a coherent hypothesis that closely links aging, glutathione depletion, mitochondrial damage, proton leakage, and the Warburg effect. These are all critical factors that contribute to the increased incidence of cancer as age increases. Let's analyze your hypothesis step by step. 1. The relationship between glutathione and aging. As age increases, the level of reduced glutathione, GSH, in cells gradually decreases. Glutathione is crucial for the antioxidant defense system, especially in protecting mitochondria from reactive oxygen species, ROS, attacks. In the absence of sufficient glutathione, mitochondria are more vulnerable to oxidative damage. 2. Cysteine and glutathione synthesis. The synthesis of glutathione requires cysteine, an essential amino acid. With aging, cells may face a shortage of cysteine, leading to a decrease in glutathione levels. This further exacerbates oxidative stress, particularly within the mitochondria. 3. Cardiolipin damage and proton leakage. Cardiolipin is a vital phospholipid in the inner mitochondrial membrane, critical for the stable operation of the electron transport chain and ATP synthesis. When glutathione is deficient, ROS attack cardiolipin, causing oxidative damage. Damaged cardiolipin disrupts the structure of the mitochondrial inner membrane, leading to proton leakage and impairing ATP production efficiency. 4. Mitochondrial dysfunction and the Warburg effect. When mitochondria fail to produce ATP efficiently, cells must resort to alternative energy generation pathways. This is where the Warburg effect comes into play. Cells rely on fermentation to produce ATP even under aerobic conditions. This is a quick but inefficient way to generate energy, and cancer cells tend to adopt this mode to meet their rapid growth demands. Summary. Your hypothesis suggests that with aging, glutathione levels decrease, leading to mitochondrial damage and ultimately proton leakage. This, in turn, pushes cells to rely on the Warburg effect for metabolism. This process may be one of the key driving factors in the transformation of normal cells into cancer cells. Such reasoning is very scientifically grounded and provides an interesting direction for further research. If you could validate these hypotheses, particularly by exploring how glutathione depletion specifically affects mitochondrial function and promotes proton leakage, it might offer more insights into the root causes of cancer. Have you considered designing experiments to test this hypothesis, such as observing the effects of cysteine or glutathione supplementation on mitochondrial proton leakage and cell metabolism. If you need any further adjustments or clarification, feel free to let me know. The current time in Washington State, Pacific Time Zone, is 7:55 p.m. on October 11th, 2024, and in Washington, D.C., Eastern Time Zone, it is 12:06 a.m. on October 12th, 2024, 62 source, 63 DAF source. 目前在美国华盛顿州太平洋时区的时间是2024年10月11日晚上7点56 source。在华盛顿特区东部时区，则是2024年10月12日凌晨12点16 63 source。